In this lesson, we're going to graph using slope-intercept form. All right, so before we get started with our lesson, let's go ahead and review what we had learned in a previous lesson. Remember that we learned that when you have an equation or function in the form y is equal to mx plus b, where the number with the variable is your slope or rate of change, and the number without the variable is the y-intercept. All right, example number 1. How do I graph an equation using the slope-intercept form? So in previous lessons, we had learned about graphing an equation where you would plug in one point or the input to then get the output. And then once you have those values in that XY table, then we plotted those on the graph and then we drew our line. Well, when we have an equation that is in slope-intercept form, it's been solved for y, we can then easily graph it by finding the slope and the y-intercept and then plotting it on the graph. So the steps that we're going to follow in graphing by slope-intercept form is that the equation has to be in the form y is equal to mx plus b. And then we need to identify the slope. We need to identify the y-intercept. We're then going to plot the y-intercept, and then we're going to use the slope to create more points, and then we'll connect the points to create a line. Well, that's a lot right there. Let's just break it down. Well, first of all, put the equation in slope-intercept form. Well, for number 1, notice we have y is equal to 3/4 x minus 1. This is in slope-intercept form, and so now we need to identify the slope and we need to identify the y-intercept, in which we had just done in our previous lesson. So remember the slope, the number with the variable. So our slope here is 3/4. Our y-intercept is -1. Remember, if you've got a minus, that makes that y-intercept then a negative. So our y-intercept is -1. And so what we're going to do is we are going to first plot the y-intercept. And remember, the y-intercept is this line that goes straight up and down. You're going to start by plotting the -1. We're going to make our first point at that -1. So we have, we have -1 right here on our graph. So now that we've plotted our y-intercept, from the y-intercept, we're going to then plot the slope 3/4. And remember, the slope is always the rise all over the run. So it's how much am I going up or down for how much I'm going side to side. So since our top number is 3, that's our rise, we're going to go up 3. Let's just grab another color. We're going to go up 1, 2, 3. And then we're going to then do our run, which is 4. We're going to go over 1, 2, 3, 4. All right, and so now we're going to have these 2 points. And once you've got the 2 points, you're able to then connect the dots, and you've got now a line that has been graphed with a slope of 3/4 and a y-intercept of -1. All right, so let's take a look at number 2. We have y is equal to -x plus 5. And this one is also in slope-intercept form. And so we need to then identify the slope and identify the y-intercept. And remember, when we don't have a number next to the variable, there is a number there, there is a 1. And so I'm going to place a 1 right here so that that doesn't make that confusing. So we're going to identify the slope, and the slope is equal to -1. Now what I want you to do, if it's not a fraction, is to make it into a fraction. So you have the ratio of the rise all over run. And remember, if we have a number to make it into a fraction without changing the value, we would just place it all over 1. So it doesn't matter what the number is. Let's say it was 2, you'd have 2 all over 1. -5, it would be -5 all over 1. So our slope here is -1 all over 1. And then our y-intercept, remember, is the number without the variable. All right, so Our next step then is, remember, we're going to plot the y-intercept. So the y-intercept, it runs in the vertical line going straight up and down. And so we're going to plot the y-intercept of 5. So we're just going to walk 0. We're going up 1, 2, 3, 4, 5. And oops, and I forgot the right color again. All right, here we go. So here's our 5. All right, so that's our first point. And then remember, to do the slope, you're starting at the 5. So starting on the 5, I'm going to have a slope of -1, 1, which means I'm going down 1, but then positive 1. So we're going to go down 1, and then positive 1, and then we'll have our second point that goes right here. And all you really need to have in order to graph a line are 2 points, because then our line goes through. And now we've got this line that is a slope of -1 all over 1, or -1, and then a y-intercept of 5. All right, question number 3. Go ahead and pause the video. I'd like for you to find the slope, the y-intercept, and then I'd like for you to graph it, and then resume the video and check to see if you have the right answer. All right, so hopefully we noticed that number 3 was in slope-intercept form. Our slope, the number with the variable, is -2, and I made that a ratio of rise all over 1, the -2 all over 1, and our y-intercept is 4. So notice then I plotted the 4, and then from that 4 we went down 2 and over 1, and then that's what created our line. All right, question number 4. Let's go ahead and pause the video again. Let's try. You're going to plot the slope and the y-intercept. I do want to mention, though, when you have your slope here, either bring that negative up to the top or to the bottom. Don't leave it out front, because a lot of times what people end up doing is then they have a negative on that 1 and the negative on the 2. And remember, 2 negatives make a positive. So I'm just going to bring that negative up and put it with that 1. And then I'll have all over 2. So there's our slope. Now you can identify the y-intercept and then graph it. All right, so hopefully then you found that the y-intercept is 5. So you plotted, the first thing we're going to do is we plotted the 5. And then from there, we should have the slope that goes down 1 and then over 2. And then you would then connect your dots to form the line. All right, question number 5. Notice we have 4x plus y is equal to 3. Well, this one, notice, is not in slope-intercept form, because to be in slope-intercept form, this y right here has to be all by itself. And so we need to now solve for y, because you cannot tell what the slope or the y-intercept is unless that y is all by itself. And so we're going to isolate the variable now by subtracting the 4x on both sides. And you have y is equal to 3 minus 4x. All right, so now let's identify the slope. Our slope then, remember, is the number with the variable, and there's a minus there. So that means that it's going to be a negative. And make it a ratio of rise all over run. And then our y-intercept then is equal to 3. All right, so now we're going to plot the y-intercept of 3. You're going to walk up to the 3. And then we're going to do our slope down 4 over 1. So down 1, 2, 3, 4 over 1. And then we're going to connect our points. And now we've got kind of a straight line. We've got a line that's supposed to be a straight line that goes through the y-intercept of 3 and has a slope of -4. All right, so question number 6. Now notice again, the y is not all by itself, so we need to solve for y. So we're going to draw our line down, and we're going to isolate that y. We're getting down to just the one y. All right, so we're going to undo the 3x by minusing 3x. All right, so we have -3y is equal to 12 minus 3x. All right, so now the negative 3 is multiplying the y. So we're going to divide by negative 3 on both sides. And we have y is equal to, all right, 12 divided by negative 3 is negative 4. Negative 3 divided by negative 3 is going to be 1, so we're going to have plus 1x. All right, so now the y is all by itself, and now let's identify the slope and the y-intercept. So again, our slope is a number with the variable, so we're going to have a slope which is equal to 1, and then make it a ratio of rise all over run. If it's not a fraction, make sure you make it a fraction. And then we had a y-intercept of negative 4. All right, so now let's start on the negative 4. So we're going on the y-axis, and we're going to go down 1, 2, 3, 4. All right, so we're at the negative 4. And then we have a positive 1 all over 1 slope, meaning from the y-intercept, don't go back up to the origin. That's what a lot, if somebody makes a mistake, a lot of times that's what they do. We're starting at the negative 4, and we're going to go up 1 over 1. All right, and so now we've got the straight line that goes, starts at that y-intercept of negative 4, and then we're going up 1 over 1. All right, example number 2, solving real-world problems. It says a recording studio charges musicians an initial fee of $50 to record an album, and the studio time costs an additional $30 per hour. And you probably remember this scenario from a couple days ago. Well, remember we said that to write that equation, we're going to have y is equal to, and we're going to spend $50. We're just going to do that one time. That's the initial fee in order to record. And then they're going to charge $30 per hour. And we know that the 30 is the number that goes with the variable because remember the slope or the rate of change, you'll hear the word per, each, every. And so we have 30x. All right, and I want to point out that this represents a total cost. And the x represents the number of hours. All right, so now let's go ahead and identify the slope. Well, our slope is the number with the variable, and the number with the variables are 30. And remember, make that a ratio of rise all over run. We're going to make it into a fraction. So we'll have 30 all over 1. And then the y-intercept is a number without the variable, so that's going to be 50. All right, so let's graph it before we answer our next question. So our graph is going to start on the 50 because without paying any hours, or no hours in the studio, you're going to pay the $50 to be able to record there. And then for every hour that you end up recording in there, you're going to go up 30 and then over 1. And so I'm going to go up 10, 20, 30, over 1. And let's do it twice. We're going to go up 10, 20, 30, over 1. And so notice then that you've got these points that go in this straight line. Now it's asking, how much would it cost after recording 2 hours? Remember, x represents the number of hours. And so I can do one of two things. I could come up on my graph, and I could say, well, after, and I probably should have labeled this right here. This is our hours, and this is the cost. All right, so after 2 hours, you come to the 2, and if you went all the way up in your graph, notice that the 2 hours, that it is at $110. So we know that it'd be $110. And another way you could do that is by taking that initial equation, y is equal to 50 plus 30x. Well, if it's for 2 hours, I'm going to plug that 2 in there for the x. So 30 times 2 is 60, and 60 plus 50 is equal to 110. So 2 ways you can go about getting that answer. For time purposes, we're going to skip question number 2. In this lesson, we took a look at how to graph equations using the slope and the y-intercept.